Hello, it's Keith here, and this is lesson 4 of the so-called MinTile series of my 6502 assembly tutorials. MinTile is of course the minimal tile routine that you can see here. It draws a tile map to the screen and it simulates sprites by using that same tile map code. Now the example here, you can see we've got our Chibico mascot moving around the screen, and I think it's control. If we press control, we can scroll and flip our sprite around. Now the problem comes when our sprite moves. We need to remove the sprite from the screen, draw the original tiles to the screen, and then draw the new sprite over the top of those tiles. But there's a problem. We don't have a double buffer, and that's by design because some of our systems don't have enough memory for a double buffer. This is a multi-platform piece of code. It exists on a lot of systems, and some have very little memory. So what are we going to do about this? Well, we're going to try and minimize the amount of flicker. What we do is we have a tile cache, and this is an update, drawing update that needs for the changes that need to be made to the screen. So the cache is filled with the tiles that are underneath the sprite. They are then drawn, removing the sprite, and then the new sprite is drawn back to the screen. But in a lot of cases, the new and old position of our sprite may actually overlap. And in that case, we don't need to draw all the original tiles to the screen, because the new sprite will actually overlap some of them anyway. And this is referred to as zero sprite in cache. The zero byte in the cache actually means nothing to do. And so by marking the object sprite positions that are about to be replaced with the new sprite, we can actually avoid drawing those and save some speed and reduce the amount of flickering. It's the flickering that we want to stop. So let's go over and let's take a look. Okay. So here's the zero sprite in cache routine, and this is the routine that we run after we've made the changes to the cache. First we make the changes for the new background tiles that are underneath the sprite, and then this will zero the entries that the new sprite is going to overlap. Now the first thing we're doing here is we're checking if the refresh tile flag is set to 0, because if it is, then the sprite doesn't need the background doesn't need redrawing at all, in which case we're just going to return. Otherwise we zero that flag so that we report that we've done the job, and then we load the XPOS and the YPOS into B and C in the 0 page, and the width and height into H and L. Now what we've got next is some code relating to what's referred to as smooth moves. Now in a lot of systems we're using the tile map, the hardware tile map, to actually draw the character to the screen, the Chibico sprite as I'm calling it. Now this means that it would be fixed to 8x8 boundaries, which is very convenient, but on bitmap systems we can actually in some cases move more smoothly. However, this means that we will be overlapping multiple tiles, because if we've moved one half tile, we'll still be half over the first tile, but we'll be over half over one extra tile as well. And so we need some extra code to basically round things up if we are half a tile in. And so that's what we've got here. So basically what we've got here is a rounding routine here. We're checking the second bit, which is the half tile bit, and if this is set to 1, basically what we're going to do is we're going to round up the X position to the nearest tile here, and then we are basically going to reduce the width of the object. Why are we doing this? Well, if we're half a tile across, then we actually want to basically we want to draw the entire tiles around, and that's going to cause the edges of the half tile across the sprite to be redrawn, because they are overlapping half a tile, so we need to redraw the full tile first. And so we're basically rounding up our XPOS and decreasing our width by 1 tile, and we're doing the same to the height and the YPOS as well there. So that is coping with that shift. That shift is a little bit of a pain. Now this does also raise a point that there is a rather significant limitation of this version of the code. MinTile is fairly crude in some places, and one of the limitations is with regards to transparent sprites. Sprites where parts of the sprite have 0 entries. For example, the feet around the Chibico character, well, they have no tiles, and that can cause some graphical glitches from time to time. Now if you look at the Chibico character here, you'll see as it moves, like there, you can see that the Chibico character has actually sprouted an extra foot, which is rather strange. And the reason that has happened is the zeroing routine is treating the object as a rectangle, but it's actually not a rectangle, because around the feet there are some transparent tiles, and the zeroing routine that we've got here isn't smart enough to figure that out. So it causes a glitch, and that causes those graphical mistakes, and it's because of a half tile movement and semi-transparent parts of the tile. Now I am hoping to write a version called MaxTile, which is an enhanced version. This version only supports XFlip. MaxTile will support YFlip as well, and it will support other tricks and techniques within a tile map. It's far more complicated, and one of the things that I am requiring of that improved version is that it no longer has this glitch. So this is a glitch that's present in MinTile. I'm aware of it. It's not ideal, but this is designed to be a fairly simple version, and this was just too complicated to fix within the sort of scope of this version. Okay, anyway, so that's dealing with our XPOS and our width and our height. What we're doing next is we're loading our tile map data in. Now this is the tile map of the sprite, because as I say, MinTile is actually a tile mapping routine. It never does any true sprites. So when it wants to draw a sprite object like Chibico to the screen, it's actually drawing a miniature tile map, and this is the miniature tile map of the Chibico character. And these zeros here are around the feet, and that zero in there is the corner at the top of the Chibico character. So that is the tile map that is the Chibico in data, my mascot in data. And so that is what's being loaded into IY here. We're then loading the flags in for the flip, and we're then performing the do crop routine, which is our cropping routine for if our character is partially off the screen. Now the reason we're doing this is we need to update the width and the height of the area we're drawing, but we also need to update the source tile map data because we might need to skip some tiles. And the reason we're doing this is we're going to look at those tiles, and we're going to look for the non-zero tiles, and we're then going to update the cache accordingly. And so we're doing this so that we've got the correct data for updating that cache. And if that returns a 0, then the object is entirely off the screen. Okay, now what we've got next is a bit of a correction. Basically the XFlip routine, it has a few glitches in it with regards to the way it works. Again, they'll be fixed in the MaxTile version hopefully. But at this stage, I basically have to make a mathematical correction to the X position if the sprite is flipped there. And so that's what's happening there. And then what happens next is we're basically going to update the tile map again. Now what we're going to do here is basically we're going to shift to the correct position within the tile cache for our sprite object. Now basically the width of the tile cache is 32 tiles, 20 in hexadecimal. And what we're going to do is we're basically going to shift that tile cache so that we've got the correct position for the sprite object, and that's because we are going to want to remove the entries in the cache that are under the center of our sprite object, because we're assuming they're going to be replaced with the next sprite draw. And so we don't want to draw the tiles that are under there because they would just be wasting time and causing flicker, because the sprite will draw over them anyway. So that's what we're going to do. Okay, so this is updating our tile map. As I say, our source tile map is 32 tiles wide. We're just loading that in there. And then what we're basically going to do is we're going to handle the zeroing. Now, what we've got next is we do have a quick change depending on whether we are doing a regular 0 or whether our sprite is X-flipped. If our sprite is X-flipped, then basically we're going to have to make some changes. Effectively, what we're doing here is we are shifting our source tile map position to the right side of the sprite, and we're going to move in reverse. So that's what we're doing here. And then what we're doing next is we are changing an inchl command to a dechl command. And there's one of two ways we're going to do this. Ideally, we'd like to use self-modifying code, and we would just write in the new address of the dechl command instead of the inchl command using this label here. That's what we'd like to do, and that's the kind of thing we're doing here. That's resetting it back to normal. That's changing it to dechl, but we might be running from ROM, and if we're running from ROM, self-modifying code won't work. In that case, we're going to just simply use a variable, and that variable will be a 1 or a 0. And that's going to basically just change the way that we're stepping through our source sprite data, either going from left to right or right to left. That's what we're going to do. Okay. So we're ready to get started. So basically what we're doing here is we are loading our counter from the width of the sprite, the amount that's on the screen at least. We're then loading in a byte of our sprite data. So that is this kind of data here. We're loading in a byte of that. And this is the data that's about to be drawn to the screen when the sprite is drawn. So we're going to check it. All we're checking is to see if it's 0. If it's 0, then it's a transparent part. And so in that case, we want to draw this tile to the screen because there's no sprite going to be drawn here. So we do need to draw the tile. So we're skipping in that case. In the other cases, though, what we're doing is we're zeroing this entry in the cache. And that's because the sprite has got a tile pattern it's going to draw to this position. And so we want to leave that alone for the cache. So we're setting that to a 0 here, and then the cache won't do anything. The sprite will draw itself later. So that's what we're doing. We're then increasing the cache position, moving to the next position in the cache. And then what happens next depends on whether we're moving from left to right, in which case we're inking HL, or right to left reversed, in which case we're decreasing HL. And as I say, we're either using self-modifying code or that parameter here. Now, once we've done an entire line, basically what we're doing is we're updating the cache position. We're adding effectively 32 to the cache address here. That's what we're doing there. And then once we're doing that, we're updating the sprite, adding the width of the sprite to the HL source of the sprite data. And we're assuming we need to do that because if our sprite is entirely on the screen, we wouldn't need to, because basically we'd be showing the entire source line. But if our sprite is half off the screen, we might be showing a fractional part of it. I suppose actually we could improve the efficiency of this code a little bit. If we had some kind of flag to say whether the sprite had been cropped, we might know that we don't need to do this. Maybe this is redundant. We could maybe have two versions of this routine, but at this stage this was a relatively simple version. It is a functional tilemap routine. I used it for my Chibi Fighter test game on the Z80 systems. I've not done anything really on the 6502, but that's really just time constraints. I just don't have the time to write multi-platform games, so I believe it's at least useful as an educational tool, and I would say welcome to take it apart and use any bits of it you find useful. Or if you think it's complete crap and you can do better, please go ahead and do better. Maybe I'll inspire you with my poor quality coding. And I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.